All right, so here we are asked a multi-part question following the curve sketching process. The first thing is to calculate the first derivative. So we'll just have 3x squared minus 12x. And then of course the negative 2 is a standalone constant, so that will go to 0. Then they ask us to compute the second derivative. So we're going to have 6x and then minus the 12x. That is a linear term, so that will go to the coefficient of just negative 12. Now, they do have this statement about how the intervals need to be separated with a union if you have two separate intervals. And then the next set of questions is where is it increasing and where is it decreasing? So of course, for increasing and decreasing, we need to use our first derivative. So what we'll do is we will take our first derivative, and I'm going to write this on the separate page just so it's very clearly laid out here, but you could maybe squeeze it in if you really tried, depending on how small your handwriting is. So we have our first derivative. Again, what we're trying to do is find increase and decrease intervals. So we know that our first step is going to be to find the critical numbers. So to find those critical numbers, we set the derivative equal to 0 or does not exist. The does not exist here is not relevant because there is not a denominator. So there's no denominator, so we don't have to worry about the does not exist. Now, when you're solving the equation, remember there's two ways to approach it. We either try to undo PIMDES, or in this case, we have a quadratic because of the square power, and so that means that we need to factor. So because we see that quadratic, we will go through a factor method. Of course, with factoring, the first thing we need to do is factor the GCF. Here we have a GCF of 3x. That will leave us with x minus 4 is equal to 0. Now that it's factored, we will set both factors equal to 0. So the 3x will be set equal to 0 and the x minus 4 equal to 0. Then divide by 3 here to get x equals 0, and then add 4 to both sides to get x is equal to 4. The domain of this function, the original function, was all real numbers, so, and that's again because there was no denominator, no square root, so both of these numbers will be critical numbers. They will be interior to the domain. Now, once we have our critical numbers, we then draw our derivative number line. And with that derivative number line, we're going to plop down the 0, plop down the 4, and plug into the derivative. Now, remember, we want to plug into the derivative right before we set those factors equal to 0. So we will go back up to right before we set it equal to 0, the factors, and that's what we'll be plugging into. This is two factors that we have. You can use this other factor to, or this standard form. That is perfectly fine too. You just need to plug into the derivative. All right, so I'm going to do this with the factored form. So for this first interval, I will plug in maybe -1, and I have 3 times -1, -1 minus 4. So the first factor evaluates to a negative, second factor also evaluates to a negative, so a negative times a negative will give us a positive. So that first interval is a positive. And then we go to our second interval. Our second interval between 0 and 4, maybe I decide I'm going to plug in 1. And so if I plug in 1 to that second interval, and again, I'm plugging in to the derivative because I'm drawing the derivative number line. So we have 3 times 1, 1 minus 4. That gives us a positive times a negative, giving us a negative overall. And then for the last interval, we have from 4 to infinity, so maybe I plug in 5. So I have 3 times 5, 5 minus 4. So that gives us a positive times a positive, giving us a positive overall. Now, once we have our positives and negatives, we then have to kind of synthesize this answer. Again, because we are looking at the first derivative is going to tell us increasing and decreasing. So this positive tells us that we're going up the hill, Negative tells us we're going down the hill, and then positive tells us we're going up the hill again. So over here on the answers, we would write that the function is increasing from negative infinity to 0, union 4 to infinity, and then it's decreasing from 0 to 4.